So there is a link on the agenda. So you may, if you have your laptop out, if you go to the main agenda, so next to IPPM where you would go onto the Meet Echo, there is a notepad for note takers button, the blue one, and it's also this link right here on notes.ietf.org, and it's just a markdown. And what we'll do, and I can actually get this, is just drop in the agenda, and then as we get to the different things, just take notes on when people are up at the mic and have conversation, what they're saying and what any decisions that are made are, so that when we go back and look at what happened, we know. Thank you. I'll try to. Can we get started? How about you can speak this slide as well.
Sure. So welcome to IPPM, everyone. I hope you're all here for IPPM. There we go. So before we get started, we need to remind you that this is an IETF meeting and we have the note well. Please familiarize yourself with it if you haven't. It's really important regarding IPRs and such, so please do. So we're running this meeting through Meet Echo. So even if you are on site, you need to register with the Meet Echo app so that you can be in the queue, etc., etc. So this is it's very important because this is also giving us an indication for how many people attend the meetings. So that's useful for planning for future meetings. It's possible to share for presenters with the app. You can actually share slides yourself, and you can step through the slides using your device. So that's pretty useful. And we have a note taker now, so thank you very much for that. We would ask for someone to jabberscribe, but probably we can relay from the chat ourselves here. It's pretty straightforward.
All right, and I have filled out the agenda in the notes tool, so you should be able to see that if you're looking at that, and just fill in the notes as we go along. Okay, so going through our agenda today, we're going to start as usual with our adopted working group documents. I think there is one agenda bash here that we got, which is to remove the stamp yang. That's correct? Okay, so we'll be skipping that one, so you get 5 minutes of your life back. Yeah, and otherwise, yeah, we'll be starting with PAM, data integrity, encrypted PDM, IOM yang, and responsiveness. After that, we're going to move on to some newer and proposed work. So here we have the quality of outcome and asymmetrical packets that we'll go into a little bit more detail on, since those have received some list discussion. We've talked about them in the past. We also have a couple lightning talks. These are the ones at the end that we're going to ask to stick to just one slide on and just go quickly through that. And then before we get started, I'm sure people who are on the mailing list already saw that, but we were very saddened to learn that Al Morton, who is a key contributor and just like the heart of this working group, passed away. since the last IETF, and so we will greatly miss him, both personally and technically. Yeah, so just ask if we could take a minute of silence right now, and you can read his obituary if you want, but let's pay our respects to Al. All right. And relatedly, there's one document that we had in the working group that Al was the primary author on. So Len, his co-author, is going to continue on that. Rudiger has also agreed to help co-author. It is currently expired, but it's going to be, actually, sorry, I think they just revised it after being expired. They still need to make a couple changes, but we will expect to move this document forward relatively shortly after that. Okay. With that, let's get started. So we're starting out with Pam. Ingrid, would you like us to share the slides, or do you want to do it yourself?
If you can share.
We can do that. Trying to find it.
Oh, it doesn't show up in the order.
Yeah, it's not in order. Here it is.
Okay, great. So thank you for the opportunity to present you updates to this work. Next slide, please. So what we're trying to achieve, we're trying to formulate their paradigm, how to assess conformance of a service that is characterized by multiple service level objectives. So when we look at the relationship between their customer and operator, these are governed by service level agreement. And service level agreement usually includes a number of measurable service level indicators that have certain quantitative expression of when the service is deemed, that define the thresholds when the service deemed acceptable. So these are referred as service level objectives. And these are not only, that includes usually their performance metrics related to packet delay and packet loss, but at the same time, that includes states, a defect state. And without going into specifics, one of the examples we give and we discuss in the document that we updated recently since the last meeting is misordering. So it can happen out of order delivery. Yes, applications can somewhat mitigate it, but at the same time, so it's known that out of service delivery negatively impacts the performance and may impact the user experience. In some cases, in some environments, for example, deterministic networking, out of order delivery can lead to really service being canceled because it impacts their critical processes like industrial control or chemical production. So what we're trying to do is we're trying to build a paradigm that allows have a single expression of this multi-axis environment when each axis is service level objective. So then basically that customer and operator, they can understand whether the service is conformant to SLA with its multiple SLOs or it's not. So that's what basically we're trying to demonstrate here in the figure, that probably it's much better, as usually they say, their figure is worth 1,000 words. So basically what we care about their period of time or periods of time, intervals, where their parameters of each SLO might be out of this required range. Also, what might be interesting, and that's something that we discuss in the document in the paradigm of precision availability metrics, is that operators may decide to have their own objectives that will give them time to mitigate their service degradation before this level will breach their contracted and agreed upon with the customer. So basically, that to detect the trend in service degradation and environment degradation, so to take some recovery actions. Next slide, please. So following on announcement and encouragement to the mailing list to review the document, we received very good comments from Bjorn and Christian, and we very thankful, appreciate it. We believe that our updates addressed, and that was confirmed by Bjorn and Christian. And the number of updates include that clarification on histogram and their basically relationship with this document. And again, in this document, we're trying not to boil the ocean, but be very aimed on creating the paradigm. And we identify several other documents that needs to be worked on. And later on, I will mention that we already started one of these documents. Also, we worked on consistency of the terminology so that we converted to using in accordance with rather than compliance to the multiple SLOs. And clarified terminology about the percentiles and percentage of packets. So basically, we decided that we'll use only percentage of package and not percentiles. Also, some editorial updates to tighten the text. Next slide, please. Discussion items. So as I mentioned, in earlier version, we had the list of items and topics that we identified as for future work. So some of them we worked on addressing in this document, and some for example, IPFix or Yang was identified to be significant enough to deserve separate documents. And we are would like to inform you that the work on IPFix document been started and the document been submitted as individual draft in Ops group. Next slide, please. So at this time, we believe the authors that we've done significant work. The document is stable. The terminology is consistent, and we'll appreciate your consideration of the working group last call.
All right. Do we have any questions, comments on this one? Could you get a quick show of hands for how many people have read any of the recent versions of this document? Cool. Pretty good. So I guess for the notes, like 7 people in the room. 7 people said they've read the recent version. That's pretty good. What do you think? Yeah. Yeah, we'll get last call started soon, right after the meeting then.
Thank you for your support. Thank you.
All right. Then we can just take that down in the notes too, that we will start last call soon. Okay. Great. Next up, let's talk about data integrity for IOIM. Do you want to share your own slides? Okay, I will do it. Oh, someone's got to want to share their own slides, right?
Okay, so Justin from ULIH. This is an update on the integrity protection of IOM. Next slide, please. So what did we do? Actually, we did a lot since last version. Based on the discussion we had in Yokohama, we also included the protection of the header. The reason for that is simple. If you protect the integrity of the IOM data fields and the header is changed on the path, the integrity is kind of pointless in that case. So it's better to have the header as well. And so having that allows to add DEX back to the document. So DEX support is back in that draft, which is quite a good news. And we needed to update the validator rule as well, so that it matches, DEX and another exception that I will detail in another slide. We also removed the asymmetric key-based signature algorithm because it simply didn't work for our case. It was discussed on the mailing list, so if you need any details, you can look back at the mail. We also improved the security section, and we also did some edit changes. Next slide. So I will reuse some slides from last presentation. You can consider the following rule as a fictive rule, but it describes the whole procedure in the draft. So basically an IOM node only signs what it writes, and you can understand that by what it adds, and fields modified by other IOM nodes on the path are excluded from the signature. So basically, it means that for the trace option type, whether it's the pre-allocated or the incremental, you would include the namespace ID, the node length. You would also have the bit number 1 and 2 from the flags, which are the loopback and the active mode. Bit 0 is excluded because it's the overflow flag and it's to be modified on the path, so you don't want to include it in the signature. And the bit 3, sorry, the last one is not defined yet, so you don't want to have it in the signature. And obviously, you have also the trace type included in the signature. For the proof of transit, you would include the namespace ID and the proof of transit type. And the H2H, actually, you have the whole header. Next slide. And so the new one, DEX option type, you will have the namespace ID. You wouldn't have the flags, but you would have the first 2 bits from the extension flags, which are basically flow ID and sequence number. So the optional fields that you see below. And you would have also the IOM trace type included. We added a small sentence in the draft, which says the optional fields, so here the flow ID and the sequence number, are treated as optional IOM data fields, not header fields. This is to favorize a little bit how it works with the procedure. And we also added a section in IANA that says a document defining a new IOM integrity protected option type must define the IOM option type header fields involved in the integrity protection of IOM data fields. So it may sound a little bit ugly, but actually this is the way we found to make sure that new integrity protected option types would define also the headers field to be included. So we delegate everything to their to each draft specifically. Next slide. So how it works? Well, the edge-to-edge option type is quite easy. So here you have the ACAP node that would sign the header fields and its data fields. And there is no transit node involved in this option type. So basically the ACAP node would only check the signature of the ACAP node to make sure that the integrity is fine. For the pod, the ACAP node would sign the header fields and its data fields. So just like for edge-to-edge, but in that case, the cumulative field is excluded just because it's modified by transit nodes. And for that option type, transit nodes would only modify the cumulative field. So basically it's like saying that the node wouldn't do anything for the integrity. So basically it doesn't update the signature. And so the ACAP node, just like for the edge-to-edge, would only check the signature of the ACAP node. Next slide. So for the next 2, we needed to add a little bit of content in the draft. And so that redefines the validator. So what we say here is that each node that takes actions triggered by fields in the IOM integrity protected option type header must act as a validator. Otherwise, an attacker could modify the IOM header along the path and change the actions a node performs. So what that means is that for DEX, for instance, you don't want transit nodes to trigger and send telemetry data upstream if it's not coming from the ICAP node, for instance, or if the data, the header was modified. And this is actually the same for the trace option type, only if the loopback or the active mode is enabled. So basically, if, for instance, loopback is used, you don't want to trigger and send back a packet with telemetry data if it's not coming really from the ICAP node. Next slide, please. So just like I explained, for the DEX, the NCAP node would sign the header fields and, if any, data fields. So remember what I talked about earlier in the slide, where we have optional data fields. And here, each transit node would check the signature of the encapsulating node. And so the DCAP node would do the same as a transit node, actually. For the trace option type, it's a little bit complicated. So the NCAP node would sign the header fields and its data fields. But here, if the loopback or the active mode is used, a transit node will have to check the signature, but the signature is actually a chain of signature in that case, because this is how the trace works. Okay, so it would have to check the whole chain up to itself. And then each transit node signs its data field as well, and the DCAP node would check the signature chain. So it's the worst case, I mean, from a performance point of view, if you have the loopback or the active mode in that case, because each node would have to check the whole chain up to itself. But I guess it's a trade-off here. Next slide, please. So those 2 points for what comes next, it's more questions for the chairs. We talked about the SEC directorate review. So will you go that way? Should we consider our last call? And also, should we update the security section of RFC 9326? So basically, this is the one that defines the DEX option type. Because right now it says that the IOM integrity protection is not usable for the DEX. So I guess we will need to update that.
Yeah, my initial impression there is like I don't think we need a BIS for that. I believe instead you could just have your new document update, just be marked as updates RFC 9326. Anyone reading that will see it gets updated. They'll follow to yours and be like, oh, look, integrity has changed this. So yeah, let's be lightweight here.
Okay.
As far as sector, remind me, have we triggered one before?
Not yet. No.
Okay.
We just talked about on the meetings.
Yeah, great. So let's kick that off. I think if you guys think it's ready for that, let's do that.
Yeah, we actually think it's quite okay right now.
Okay. I think there is a question of, do we want to get that over and done with before we kick off the last call? That might be safe to essentially have the early sector review, make sure there's not like huge red flags we're going to hit, and then we'll go from there.
Yeah, sure.
Okay, great. Okay, so yeah, for the notes, we'll do a security directorate review first, and then depending on the result of that, we'll kick off the last call later. Okay, any questions, comments on this beyond just the process? How many people have read or reviewed this document? Quick show of hands. One. Okay, well.
So feel free to do it.
Yes, please do. I mean, we will kick off the last call as well, and then we'll definitely want more people to look at it. And I know we're missing some of the other kind of core IOAM folks from this room right here.
Yeah.
So, all right,
awesome.
Thank you. All right, I think next up we have PDM. Do you want to share your own slides or do you want me to do it?
No, you-
Ah, man. Someone's gonna.
Okay, next, please. Okay, so we had discussed some changes to the draft in 116. We've done them. And so I think we're ready for another sector review. Please let me know. So I'll explain the changes again. So basically, we've got a number of fields in PDM v2, and there's only one that really requires us to do encryption and decryption in real time. So and if we take that out, then we're good. We only need to do encryption, and then we can decrypt offline. Next, please. That keeps it really, really simple. Yeah, next. So it's the packet sequence number last received that's filled in by the other end of the connection. And in order to know last received, he has to see what was it that I got, so he can stick that into the last received. If we eliminate that field, then we can just speed up the flow just tremendously. Okay, next, please. So what we're proposing is we just pass that field, PSNTP, which is the packet sequence number for this packet. If we pass it in the clear, then the other side doesn't need to decrypt it. He can just stick it in that field and just encrypt and be on its way. Yeah, and that just, it simplifies the whole draft. You know, we've taken out all the topology, primary server, secondary server, just a huge amount of stuff. It's probably a third of the size that it was, and much, much simpler to implement. Next, please. Yeah, so this is the current packet layout, and then what we propose is to have that field passed in the clear. Next, please. So fairly simple, and I think we're ready for review if everybody agrees. And the thing about passing the thing in the clear, it's also following HPKE specifications for what you're allowed to do.
Hi, I'm Matt Mathis. I'm wondering if you've had any security review of this.
We had an initial security review, and they said it was fine so far. They just said it was early. So the initial review had to do with how we're using HPKE to create secrets and so forth, and they were pretty good with it.
They might also have an opinion about sharing the same information, both encrypted and unencrypted.
They very well might. They very well might. But that's why I say is like the unencrypted information we use in HPKE. HPKE requires one field to be sent in the clear, and this is what we are doing.
Martin Duke, Google, maybe a silly question, but like, what's the difference between having this epic field and just 4 higher order bits in the packet number?
That's
The epoch up here?
What?
yeah. That's a yeah. I have to go back and look at the draft for that one. It's it was a cryptography thing. I'm a
Okay.
protocol geek, not a cryptography geek.
I hear
but
you. Okay.
Yeah.
All right.
It was one of the it was the cryptographer who
You said the magic words as a cryptography thing.
I know,
sit down.
exactly. Out of my pay grade. Okay, that's yeah. That's what they said to do.
Just a quick question here. Maybe this is just like a bug in the slides, but I think here you're highlighting the packet number last received, but elsewhere we're talking about passing the PSNTP in
the
this
clear.
packet. Yeah.
Yeah. And so what? No, that is
Okay.
actually, shockingly enough, that's actually correct.
Okay. So
What
I'm
happens
missing something
is
then.
PSNTP becomes PSNLR for the other side.
Oh, I see.
You see what I mean? It flippity flops. That would be the technical term. Yeah.
Got it.
So yeah, as I say, I think You know, this is much less about metrics than the cryptography. And as I say, we did have one sector review already, and we believe that we are following HPKE accurately because they required another field. We were actually throwing in another field in the clear beforehand. It was a counter. Yeah, I mean, and don't ask me why HPKA requires that. I have no idea. So that's, but that's how HPKE wants it. And so we're using PSNTP as the fields that HPKE wants sent in the clear. Yeah.
Okay.
Yeah. So sector is probably the right place.
Matt, it says you're trying to share slides. Are you just trying to be in queue or okay? Now we know. Okay. Any other questions or thoughts on this one? I agree. We just want the security review for that.
Yeah.
That sounds reasonable. I guess, is there any concern about that this packet number being visible? Like, I assume there's.
I mean, it's like, yeah, of course there's something, but it's like, it turns out that what HPKE wants sent in the clear is the equivalent amount of exposure,
Of the sequence number, essentially.
Yeah. So 6 and 1/2 dozen of the other. Because I mean, that's essentially, I mean, as I say, again, I mean, I'd have to, I mean, not just it's like, yeah, I mean, I can try reading the HPKE draft, but for all the good that would do me, I mean, as I say, they need to really say whether that's a legitimate use or not. I mean, that's why we have a cryptographer on the team. Yeah. I know the performance metrics,
Right.
Not that part.
I guess from a protocol standpoint, what for the PSN, this packet, the PSNTP, is that something that is just monotonically incrementing generally? Is there anything that a onlooker would be surprised about in that value of like, oh, it totally changed and that tells me something strange happened? Or is it very predictable?
Yeah, that's a very good question. A PSNTP is monotonically increased for each packet sent. But it'll wrap too.
Sure.
It'll wrap. But again, as I say, whatever that number HPKE wanted had exactly the same.
Yeah. Okay. If it is a monotonically increasing one, that is very similar to all the other uses of the HPK input that I'm familiar with. So, okay, good.
Yeah.
All right. So, sounds like we have 2 documents for sector review. All right.
Great. Thank you.
Thank you. I'll reload my page. My meet echo is haunted. All right. And next up, we're going to talk about Yang. All right. So, do we have slides for that?
We do.
Here we go. Yeah. Out of order. All right.
Hello, everyone. This is Tianran from Huawei, and I would like to talk about the Yang data model for IOM. And next, please. Actually, there are comments from IETF117, and many people think IOM DEX is very useful, and would like to see it in this draft. So we add this direct export profile back to the Yang model. It's generally like this. And next. Here are some more detailed comments before IETF 117, and I would like to discuss with you. And firstly, Thomas and Greg asked to clarify the scope to configure to the configuration only. Yes, we agreed on this. And Alex suggests to add also a flag to enable the optional sequence number in IOM DEX. Yes, we also agreed, and we set the default value to false. And third, Grad suggests to remove the I1 port option from this draft, if I understand correctly. And we think RFC 9197 describes I1 port option, and the security is out of scope of this draft. So, and we see the our data integrity is still in working group. So maybe the authors of that draft may consider the security issue. And next, Greg suggests to use different names for leaf enabled in grouping IOM admin config and tracing profile containers. We think firstly, it's not a critical issue. And secondly, this Yan model has already passed the Yan doctor review. So we believe it's not an issue, and we think we can keep it as it was. And next, Greg asked for a more accurate description on IOM DEX. And yes, we agreed, and we put the detailed or more accurate description in the latest version I just uploaded yesterday. And Greg also discussed should there be an action transit. Actually, this action was in the early version, but we cannot find a use case, so we removed it. So if we really want to put it back into the draft, I think we need more input from the working group. Yeah. And comments, please.
Okay. Yes, Greg Mirsky Erickson. I greatly appreciate their constructive consideration and discussion that we had, and I will review the latest version. For the action transit, I can just quickly mention that without some distinct type, I was wondering, so we have encapsulating node and we have IAM decapsulating node. So without any distinct type for the transit node, it seems that the transit node is not controllable at all. Because it cannot be encapsulating node, it cannot be decapsulating node, but it has to be something, right? So whether call it it's action transit node or just action IAM, if we want to be able to control IAM functionality on a node which is neither encapsulating, neither decapsulating, then we need to assign its role. That was my motivation.
Right. It seems I understand your position, and I got an idea. Maybe I can put the action transit as the default action.
Again, so I'm not specific about that it has to be referred as action transit, but what I thought of is that if we want to control IAM functionality on a node which is not encapsulating, decapsulating, then we need to create something.
Yeah. So as I suggested, we can put it as
let's think about it.
Default action.
Yeah, we can do it. We can continue on a list, but I just wanted to share with others so they can think of provide their ideas and share on the list. Thank you.
Okay, thank you. And next, I think we already incorporated the comments in the latest version, and I think after the revision, based on the discussion just now, and I think it's ready to move forward. Yeah.
Yeah, greatly appreciate that you take all of this into consideration. And maybe you want to continue this discussion with Greg first, and then based on this, we can make a decision on doing a
Okay,
last
no
call.
problem. Thank you.
Okay. All right, and then last for our working group documents, we're going to talk about responsiveness.
Oh, can you hear me?
Yep.
Awesome. So thanks, Tommy. This is going to be a fairly short update on the responsiveness draft. You can move on to the next slide. That draft hasn't updated since the last IETF. In the last IETF, we presented a major algorithm change to the draft, and so we have been working on implementing this algorithm change, making sure it works correctly. There are now 3 different implementations of the responsiveness algorithm. There is and has always been the network equality tool in macOS that is now available in the upcoming in the beta. It will be in the upcoming macOS release, the network equality tool. Will Hawkins is the leader of the open source Go responsiveness tool that is based on the Go programming language and can run on any platform that supports the Go environment, which is basically, I guess, everything. And then there is the LibreSpeed implementation by Felix Godet. LibreSpeed is a web browser-based speed measuring tool, and it's open source as well. And he has implemented the responsiveness methodology as well. So we have been able to validate that one can implement this methodology in a web browser as well, which has different types of constraints compared to a native environment like the Go responsiveness or the network quality tool. So that is the update in terms of implementation status. In terms of the draft, we all need to do some refinements, some wording, and then we can, in my opinion, move the draft on to get to the working group last call. But before I finish my presentation, I want to point this community here also to our, what we created, the RPM community, which is a group of people enthusiastic about improving and measuring networks. It's the environment where we have been working on implementing the responsiveness tools, the open source tools. It's currently being led by Will Hawkins, who is also here at the IETF, and you can find him and go talk to him. We are working on these open source measurement tools. We are also working on improving open source implementations like web servers, networking stacks, and so on to, in general, improve responsiveness on the internet. So I invite everybody to join this community. You can go on to the next slide. Yeah, it's about 7 months old. We have 50 plus members. We work on LibreSpeed, IETF2, Golang, Apache traffic servers. We started looking at HTTPD. I see some folks here in this room are also part of this community. So whoever is interested about this, please come and join the community. And that's it for the update on responsiveness from my side. If there are any questions, I would be happy to take them. So from my perspective, IETF draft is basically, is in my opinion, good to move on to the next stages, to the working group last call after, if we need to do some minor wording updates and so on. But yeah, I don't know what's the plan from your side.
I think that sounds reasonable. It would be great when you published a new version, and then, yeah, with your updates, and then we could probably consider making a last call. And please, everyone here in the room, please read the document if you haven't, and yeah, be prepared to review it.
Cool. Thanks.
Yeah. I mean, I guess we could do a show of hands like we've done for the other ones of, have you read this document? All right, cool. Got like 5, which is good. And so Christoph, we will get one more update and then we'll do last call, or no?
Sounds good to me.
Good. Also, I guess, regarding the RPM community, cool stuff, and perfectly fine if you have interesting outputs of that. Fine to bleed over into the IPPM list if there are things that you want to report to the broader group. The working groups exist on the mailing lists. That's where they mainly happen. So I think it'd be great to see any outcomes or even just the same invite that you're doing here to go out to the list so that people are more aware of that and can get involved and have more crosstalk between the communities.
Yeah, absolutely. Sounds good.
All right. So now we're going to move on to some proposed work with quality of outcome. Do you want to share your own slides? No. Oh, man.
Yeah, so my name is Björn Ivarteigen. I'm with the Domos, and I'll be presenting this overview of the quality outcome draft, internet draft. So next slide, please. So this is the agenda. I'll go through sort of the motivation for the work, the design goals that we've been trying to work to achieve, and then the solution that we propose, an example, and the implementation status. Yeah, next slide, please. Okay, so the motivation is basically that, users consume applications, not networks, and a network quality metric therefore needs to somehow reflect the quality of the applications running over the network. And that's what we're trying to do. So next slide, please. And finding out how well the applications work is challenging. It's complicated. Many reasons for that. There are a bunch of different properties of networks. Bandwidth, latency, idle latency, latency under load, working latency, all kinds of metrics that you can use. And then networks are complex. There are many technologies involved. And then the application side as well is complex. There are layers on layers of optimizations to deal with the underlying variability and complexity. And then to sort of top it all off, user experience is complex as well because it's subjective and not all users agree on the same thing. So this is just to say that we know that this problem is complicated, and the solution that we're proposing is one tool, right, to help point us in the right direction. And we're not proposing a sort of sweeping one solution to finally fix this problem. But I hope that we're contributing something useful regardless. Okay, so next slide, please. Okay, so the design goals that we've been trying to work towards is to make a quality metric that will be useful for the applications, the users, and the operators of the network at the same time. And these stakeholders have different considerations for what they need from a quality metric, basically. So next slide, please. The end users primarily need something that's understandable. It needs to map to the actual application outcomes, and it needs to be honest and objective. You need to get the same result every time. And I think there are several good metrics that are understandable for end users. Certainly RPM is one of them. And I think the quality of outcome metric is complementary to that. Okay, so next slide, please. Now, from the application side, they also need the metric to be objective. And they need it to be basically a good way to assess whether or not an application will work well over a given network. Like if the network can produce this level of quality, then I know that my application will work well over that network. And because applications are diverse and have different needs, we also need the metric or the framework to be able to describe a large set of different application requirements, because not applications are the same. Okay, next slide, please. And then for the network operators and vendors, the main thing, I think, is to be able to pinpoint the source of problems. If there are, so if you measure the end-to-end path and find that it's not good enough for some reason, then you want to be able to go back, look at your measurements and be able to spot where the error is, basically, or which segment or which part of the network or which operator or like whatever, which device is the source of your problems. And I would argue that a very useful property to move in that direction is to have metrics that are composable. So that's why we're basing our proposal on the quality attenuation work from the Broadband Forum, where they define a network metric that is basically a way to, and I get to it in more detail later, but it's a way to describe latency distributions, and they are composable. So you can, if you measure one segment and then another segment, you can add them up to basically get the result for the end-to-end. Next slide, please. Okay, so these are just links for your convenience. Next slide, please. And yeah, so this is the Broadband Forum standard TR452 and or QED is the most recognizable word, I think. It's a mathematical framework for network quality, and it measures how latency distributes. That captures all the other qualities of latency that you're used to working with. So if you have the full distribution, you can work out what the mean and the standard deviation or the jitter and all of those other things are. It's composable, and if you know the quality attenuation of a network segment or link, and you also know the network or the quality attenuation of another alternative for that path. So if you want to switch out, if you want to upgrade your network from like DOCSIS 3 to DOCSIS 4, and you know the quality attenuation properties of those two technologies on that path, then you can basically do an analysis before you deploy and see if this is the performance benefit that we expect to see. So it's very useful for that kind of analysis work. Okay, next slide, please. Yeah, so quality of outcome is we're trying to find a middle ground between these very subjective and hard to measure things that fall under the quality of experience umbrella. And on the other side, sort of single metrics or things that you can measure from the network, but that don't by themselves reflect the application performance. So like bandwidth and latency and packet loss. Next slide, please. Yeah, so this describes the formula. I won't go through this because I have a picture later, but if you want a short description, that's in the slides if you find them later. Next slide, please. Yes, and this is just to say that the quality attenuation metric is very useful for both top-down and bottom-up analysis. So you can do an end-to-end. You can do an end-to-end measurement of a network and get a good description of how what the latency in that network is, or you can do a component-based analysis and add them up to get like if I place all these components after each other, then this is the end-to-end performance that I will get. Next slide, please. Yeah, so this is the one that best shows what we're actually proposing. So quality outcome, as we define it in the draft, is basically you can provide a list of percentiles, and then for each of those percentiles, you say this is perfect. So if the network provides latency percentile that is better than this, I don't care how much better it is. It's just, this is basically, if the network is better than this, other factors is what determines the user experience. So that's why the quality of outcome equals 100 is on the left side in this plot. It's basically, it's specifying when the network starts to even affect the application. And then on the other side, on the right side, we have a bunch of zeros, and that's basically the threshold for uselessness. So at this point, if the latency is this bad or worse, I basically consider the network or the application performance to be useless. We say that, we don't really care about how much worse than that it gets. It's just, this is useless to me. And then we just do a linear interpolation between those 2 points. And then we take, because it's a list of percentiles, you will get different scores for each of the percentiles. And then we just take the worst one of those. So in this case, the CDF of the latency, it's better for the 50th percentile, better than perfect for the 50th, better than perfect for the 90th, and then it's not quite perfect for the 99th percentile in this case. So you get 80 or so for the quality of outcome score. And yeah, let's do questions right away if you.
Yeah, Martin Duke, Google. I guess I don't understand why there are 3 different 0 to 100 lines here. Like, isn't there a latency that is perfect for the? Are these 3 different applications, or are they the same application?
So the way we define it in the draft is that you can basically supply an arbitrarily large list of percentiles with these thresholds for each of them. So it's a way that so you can basically specify a minimum latency that you like if you would do like the first percentile or 0th percentile if you like.
Yeah.
And a maximum if you do the 100th one, or anything in between if you like.
Well, like a perfect experience is 100% of the time I'm below some latency, right? Like.
Sorry, I didn't understand.
So I mean, like I actually I think it's quite novel and interesting, this concept of like how much of the time, like where am I between minimal quality and like perfect. But it's unintuitive to me to define perfect as a like a percentile thing. Like it's either perfect or it's not, right? Like, what does it mean to have like an 85% chance of being perfect? I'm not phrasing this well.
No, okay. So if I understand, is your question about the having different percentiles, or
Well, yeah. So
how do you interpret the score?
I understand the CDF curve. I understand that measurements have percentiles, but in terms of your, like, my intuition of this, having thought about it for 5 minutes, is that you should have a single line with 0 to 100, and to the extent that that CDF curve is below 100, it is perfect, right? And to the extent that it is between 0 and 100, it is somewhere between perfect and adequate, and to the extent that it is past 0, like the thing is bad.
Yeah.
I mean, okay. I think I made my point.
Doing that will work within the spec, because you can have a list of one element, right? If you want. The reason we've done this way is because now you can define an arbitrary CDF for perfection, and then an arbitrary CDF for uselessness.
Okay, yeah. So what I'm seeing is definitely a special case to this. So I guess the framework is fine. I still don't grasp the use case what you're describing, but I'll get there. Thanks.
Thanks.
Just following up on that, so that I also am sure I'm following correctly. So my impression is that there's essentially infinite number of these 0 to 100. Like, for every possible percentile in here, I could have a different set of 0 to 100. Is that correct? Yeah. And so I guess potentially the question coming out of this, because Martin was saying, you could just have them all be the same all the way up and down the graph, that the 0 and 100 are the same.
Yep.
In this case, in this example, what determines why at the P50 case it's over here, and at the P99.9 case is much more tolerant of slowness.
Yeah. So, to be honest, I've just made these up, right? So it's
Sure.
not necessarily true that this is a good way to do it, but my idea when writing this up was that basically your applications can have various mechanisms to deal with network variability, right? And so you might have a video application that will smooth over if it drops like one frame or something. So it's fine if every now and then you lose one packet, but if you lose many in a row, or if you lose them too often, then it stops working, that kind of thing. In which case you care about some lower percentile for your basically like which is basically your base round trip, right? The lower percentiles of the latency.
Yep.
And then you can specify like how much packet loss or basically how many late packets do I tolerate within my whatever the application has done.
Right.
That's what
Yeah.
I was thinking of when I did this.
I think
But I'm not sure
maybe-
exactly how you would translate between them, because you basically need to test it out, I think.
Right. I think it may be clearer, and correct me if you disagree, but like to just draw the ideal CDF of like, I'm perfectly tolerant of this CDF, because like, understanding that the P99 won't be as good as the P0 because, caching or whatever, like there will be some latencies that I hit, but here's this perfect one. And then here's the one that is completely terrible. And then I have my actual measured CDF.
Yep.
And essentially the worst point on that measured CDF is my overall quality of outcome score.
That is actually where we started with this, where we would like draw a perfect CDF, draw a useless CDF, and then have the measure one in between. And the reason we went with basically subsampling them is because then it's much easier to specify what you mean by, or then you can have a simple list like these are my requirements instead of having to specify a CDF. So it's just a practicality basically, but yes.
Sure.
So to follow up on our extremely well-dressed work group chair, like some like I know like I've only spent like a minute, so maybe there's something obvious I'm missing here, but maybe like an example of like a use case or an application that has this multiple CDF. I still like suspect that you're kind of double counting the time variability of this, and maybe like not here, but just the next time we iterate through this, maybe some sort of application that uses this functionality instead of just having the single continuum. Because I'm afraid that what you're doing is you're defining like a 50th percentile, and then you're looking at the CDF at 50th percentile. But anyway, yeah, some examples might be useful.
I agree. Thank you.
Rube Goldberg, LibreQOS. My question is mostly about the sampling rates that you're considering this data at. I have a strong predilection for 10 milliseconds or less. And yours is?
We don't specify the sampling rate, but in theory, theoretically what you want is to specify the instantaneous probability distribution for your one sample of latency. Like you want the instantaneous metric basically. If you can, but practically you can never achieve that. So higher sampling rates are better if you want to get a good approximation. But then, of course, sampling a lot, you affect the actual measurements, because then you're inserting packets unless you're just observing a queue or something like that. So yeah, it's a very important consideration to take into account for sure. Thank you.
Yes. Greg Mursky Erickson. I'll put the DBF hat on. I lead the work on performance experience application testing project stream, where the QED is being produced, documentation. And as Bjorn pointed out, so several documents already been published available to the public, including the applicability of active measurement protocols to QED measurement, and the cases consider it as a T1 polite and stamp. Also, there are some discussions, and everybody, well, if your company is a member of BBF, welcome to join in applicability of hybrid methods to QED. So it's some interesting discussions ahead. So if you're interested in this work, welcome.
All right, next slide. Yes, so this is the implementation status. We've got a library in C that basically does, if you have a way to sample latency, then you can put them into the library and get the latency distribution and calculate the quality of outcome from that. And then we have done the same thing in Go responsiveness that Christoph mentioned. So there's a flag you can add, and then you get basically quality outcome statistics for a couple example requirements there as well. Yeah, next slide, please. I think, yeah, and this is just if you want to have more detail on how that implementation works. We're basically putting all the latency samples into T-digest, which is a way to compress distributions. And then we track like the min and max and sum of squares and stuff like that as well. And if you want the like inter-packet delay variation, you need to also track those because you can't get those back once you put it into the T-digest. And then once we've done that, it's simple to compute a very large range of metrics of the latency, so you can get like the mean variance, percentiles. You can do RPM, quality of outcome, all kinds of stuff. So, all right, I think that's my. Yeah, maybe I have one more slide. Yes, thank you. Okay, I realized I should have added a next question mark slide, like everyone else had, for next steps. I didn't do that. So yeah, we should discuss that as well if you. Thank you, guys.
Thank you. Guess how many people have read this document? Show of hands. Got 3 or 4. Yeah. So yeah, I mean, we've definitely had some discussion on it. We could do if we want just like a little hum tool to see if people are interested in adopting this, because we have this in the other one. So let's do that. All right. So while we're getting this ready, we'll have a question. And so if you want to, so what's our question going to be? Are you interested in adopting QO? So on the MeetEcho tool, raise your hand if you're interested in, if you think that we should adopt this document, and do not raise your hand explicitly if you don't think we should adopt this document. People finding the tool. Oh, here we are. You have to be on MeetEcho.
Yeah,
which you should be to do the blue sheets. And I'm happy to wait for you to, if you want to. We can give time.
And I guess I can say as well, please get in touch if you're interested and want to collaborate on improving the draft and improving the metric. And yeah, we know there is very much room for improvement. So I would welcome any feedback or comments from everyone. Thank you.
Martin Duke, Google. So I don't want to make it like a special be especially strict for this document because I think we've probably done this before. But I'm a little concerned that we have 3 times as many votes to adopt this as we have people who've read the document. And I know that I did not vote, and I was one of the 4 that read it.
Yeah, I want to, do follow up on the list.
Okay.
I just kind of want to get a sense.
Yeah. All right.
From
Fair
everyone
enough. So what you're really asking here is, are people intrigued by this presentation and the use case it presents?
Yes, and I think we'll want, more than just confirmation. We want people to do a review of it.
Okay.
on the
Super.
list. But do we think that this work is work that we would like to take on in the group?
Okay. Thank you very much. That's lovely.
Absolutely.
So I think we're converging here. It's like 11:05. So any of you who don't want to see this, do you want to comment to that? Is it based on what you saw in the presentation, or are you one of the ones who have read the document? It would be interesting to get your feedback as well. Or you can take it to the list, but if you have anything to say now, it would be interesting.
All right. Yeah, I mean, it's perfectly fine not to do that. But again, if you do have a reason that you click do not raise your hand, we'd be curious to hear that. All right. Thank you.
Thank you very much.
All right. And Greg, are you going to present the next one?
Yeah, if you can help me. The name is a bit.
What's the name of the document?
Accessibility. No, not accessibility.
Yeah, the name of the
asymmetrical.
Yeah, but the name of the
asymmetrical
presentation was a little bit different. It's stamp that one, yeah.
Yeah, stamp extensions one. Yeah.
Yeah.
Perfect. Thank you.
Okay, so this is first presentation on a new extension that we're proposing. We managed to generate some good discussion on the mailing list. So, and updated the version. So here's what we proposing. Next slide, please.
Sorry.
Yes. Okay, so it has some interesting development if you follow the discussion on the list. So originally, there's extension to control reflected test packet was intended solely for rate measurements. So the rate measurements then been discussed, and that's where it was experimented with a T-WAMP so that a single test packet sent by the session sender, and especially because STAMP operates in a symmetrical form, so that by default it will be sending a single packet of the same size, reflected packet. For the rate, for the benefit of the rate measurement, it's beneficial for the protocol to be able so that reflected packets can vary in the length and even in the number. So for example, a sequence of reflected packets will be triggered by the single packet sent received by the session reflector. So that's how we came up with a proposed extension, TLV. So we can define, the session sender can define the length of reflected packet, the number of reflected packet in the sequence, and interval between these packets in that single sequence. So then realize that this gives us an interesting property, because what happens if the number of reflected packets is 0? Oh, STAMP turns in a one-way measurement protocol, because the session sender tells the reflector, oh, don't send me any reflected packets. So the measurement results can be processed based on a local policy by the session reflector. That's an interesting property. And then when the first version, it generated some ideas, exchanging the list, as you saw. And next slide, please. And can realize that managing reflected packet might be beneficial in performance measurement in a multicast network. Because one of the challenges of measuring in a multicast network is that it generates a flood of reflected packets. And because they go to their sender, so the sender now might be overrun by reflected packets. So being able to control reflector in their reflection of the test packet is beneficial, but that might need some additional instrumentation to do selective reflection, so that only subset of active tails in a multicast distribution tree respond with the measurement as in a two-way measurement protocol. So thus, what we're adding here is a sub-TOVs that allow to do such filtering on the layer 2 information or layer 3 information. So it's either layer 2 or layer 3. So one of is that because if, for example, equipment of the same vendors being used as a tails, so they will likely to have some common part in their MAC address. So this will be able to do some masking of their 48 bits. So to identify this subset of tails that needs to respond. And similarly, with the proper IP address assignment to the hosts, that in a multicast, for example, broadcasting video distribution could be identified in the layer 3. So the next slide. So this is a sub-TOV that proposed for layer 2 filtering of reflectors. Next slide. And this is layer 3. So it could be IPv4 or IPv6. So it will have variable length, and address family will explicitly identify whether it's IPv4 or IPv6. And prefix length is basically helps you to do identify the significant part of the address that you want to match on. Next slide. So there needs to be some additional work that we already identify and we'll continue working. So because session reflector, it can act as attenuator. So basically suppressing some in multicast environment from reflecting packets, or amplifier if it reacts more than single reflected packet to a single packet. And then the question is, so when we say in this extension TOV, number of reflected packets is 0. So we turn the it to operate as a one-way protocol. And then the question, what we already started discussion, and we welcome you to the discussion on the mailing list, is whether we want to have extension that fetches the results from the reflector, or it should be done only over the management plane. So basically keep it out of the protocol itself, because it's not a measurement. But at the same time, so there might be pros and cons for either. And also we welcome your questions, comments, and we are inviting cooperation on this work. Thank you.
Thank you. Rakesh is in queue.
Rakesh Gandhi from Cisco Systems. Thanks, Greg. It's good work. Support the work. I think working groups should take the work. Few questions. It's mostly the clarification. One was that I think the reflected packet can come with a different size, but it wasn't clear what would the packet look like. Would it be a different padding TLV, or how would it be coming back? So it's not in the draft, I think.
Yeah, thank you. Again, yes, there are some details we're aware that we need to clarify, and we had a discussion because it's okay. We need to finalize the wording about basically what happens if their test packet that's sent by the session sender includes some TOVs. Yes, so basically if we want to have a larger packet, then it will use padding. But what if the requested packet is shorter than the send packet? So should we allow that, or we will say no, the minimum will be symmetrical and you can only send larger packet back. So that's something that we want to open discussion and open to your input.
Okay, yeah, that's good. Second question, it wasn't clear to me. So in case of multicast, I think it can have an address or a subnet, but if I want more than one leaf node to reply, but not all of them. So can we have multiple addresses or?
No, that's a good question. That's something that that's a new idea, because what I believe that what we envisioned, that this is a mask. So basically their layer 2 or layer 3 produces, yes, you can produce a host, right? So basically, for example, if IPv6, so your prefix length will be 128, right? So then basically you are doing exact match. But what about if your prefix length is 48 or 64? Okay, so basically then you have some set of hosts that probably will match to this network address, right? And then they will respond. So that's basically the idea that we're putting for layer 2 and layer 3, that you produce, you define some subset of systems that might respond. Whether they are physically present, oh, that's a different thing.
And another question, in the stamp processing, when it replies, we switch the SA and DA and you reply. It wasn't clear in case of multicast, but there is no, I don't know what is in the DA and how would you reply? And the question would be, when you reply, how would the sender know which leaf node replied, right? So,
right. Yeah, that is another detail that we need to clarify. We're aware of it. And yes, basically that we need to specify. The idea is that wording to be something that the source address of the test packet must be used as a destination address, and the session reflector must use one of these, its routable addresses as a source address.
okay. Okay, thanks again.
But yeah, that's some wrinkle that we need to clarify and put in.
Yeah,
right
again, good
wording.
work, and I support the work.
Thank you.
Martin Duke, Google. So I've skimmed this document. Oops. I've skimmed this document, and I'm not going to claim to have read it, but I can see the power of what you proposed here. So it's very interesting. As usual, I'm concerned about security and congestion. A 32-bit packet count field triggered by a single packet with potentially quite small interval. And like the security considerations, like you're like source IP filtering, right, which is like, that's pretty weak sauce.
Yeah, actually, you're spot on. So okay. What we discuss and what we intend to do is that we say that it must use HMAC TOV, so that basically it has to be authenticated.
Okay, that's a good start.
Right. So yes, we were thinking about some sensible boundaries for these fields. Basically, not to say, okay, you can say 16 million packets triggered by one, but yes, to have some sensible ranges.
Okay, so it's good. It's better. I don't have a terribly constructive suggestion for what else you could do here, but I'm still a little uneasy about the ease of like
that's
a misconfiguration of a trusted device, for instance, completely melting the network.
Yeah, that's why we pointed out that we need to work on especially these concerns with the amplifier. So basically, right, when this turns reflector into amplifier.
Yes, and so it's probably too much to like rate limit to like 1-to-1 or something like that, or 1-to-3 even. That's probably defeats too much the purpose of what you're trying to do. But I'm before we adopted this, I would like to have at least a story on how we can mitigate these sorts of risks in a pretty robust way.
And again, from our discussions, who joined the work already, is that the number of reflected packets in the multicast mode must be 1.
Yeah.
Or at least not more than 1.
Got it. Yeah, that's helpful. Okay, thank you.
Okay, thank you. Oh.
Chime in.
Yeah.
Xiaomi ZT. Quick question, just raised in my mind. Can the stamp extension used for multicast environment be used for beer environment?
Actually, great point. So I'll be making some review of OEM work in the beer, and I'm intended to reference this document so that people can look at it, and maybe it will be interesting for them. But yes, short answer to your question is that because beer is one of the multicast environments, that might be useful in a beer environment as well.
Okay, thank you. Interesting jobs.
Thank you.
Thank you.
All right, thank you. So, I mean, we definitely seem like some people have read this. How many people have read or skimmed this document? Cool. All right, so about 4 or 5 people have read or skimmed that. That's good. As Martin was alluding to, maybe things we want to dig in before adoption. But I guess let's just do another little on-site home thing of, are you interested in adopting this work? We'll do a formal adoption call and we want to work out some of the questions, but is this something that we should queue up for that? So please use the Meet Echo tool. Once we get the question out, and raise your hand if you think this is work that the group should take on once we have a bit more discussion review. All right. Cool. That seems like it's stabilized. Yeah, pretty clear favorability here. If anyone who didn't raise their hand wants to speak up to explain why they think it'd be a bad idea to cover, please do so. Or otherwise, we'll have more discussion on the list. Okay. Great. All right. So that concludes our main part of the agenda, and now we're on to just some lightning talks to go over some proposed new work. And so first up, we have some alt mark deployment. Do you want me to share for you?
No.
Okay. Oh, I think it was what, 13 to 2. Okay, which? Yeah, I'm trying to find them. They're out of order. It's not this one.
No, yeah, it's this.
This one?
Yeah.
Yeah. Great.
Okay, so next slide.
Yeah. You get one slide.
Yeah, this new work aims to answer a question: how to deploy alternate marking. Basically, we want to answer the question how to deploy alternate marking. Basically, you know that RFC 9341 and 9342 have been published recently, but during the discussion about the last call and the ISG review, it was sometimes raised the point that it is not clear the part about the manageability of this methodology. So we try to propose a framework for the deployment. In particular, you see that the overall architecture include the marking node, the transit node, the unmarking node, or the encapsulation node, and the network management systems, because to deploy alternate marking, you need the network management systems. And we try to explain the configuration aspects and also the exporting aspect. So the draft aims to clarify the following aspect. So the deployment domain, both RFCs, the proposed standard clarify that the alternate marking must be deployed in a controlled domain. So we, of course, continue to with this requirement of limited domain. We define the rule of each nodes, the measurement nodes, the type of measurements according to one flag, 2 flags, or other multi-point measurements. And then we give also operational guidelines, the kind of information that is needed, the measurement frequency, few consideration about the computational load, and the important aspect about the configuration, it can be done through Young model, PSEP, BGP, and the reference with the relevant work that is done in other working groups. And also the export that can be done through IPFix or network telemetry, Young push, and so on. Then we also make a description about the different encapsulations for which the alternate marking has been already extended, so IPv6, SIV6, BEER, and so on, and finally the security aspect. So this is a new work. We hope to have a feedback, in particular to understand whether this work is clear and clarify the deployment aspect of the methodology. So I think that's all. Comments are welcome and inputs are welcome.
All right. Any questions, comments? Okay. Do you want, yes, the hop by hop.
Yeah. Yeah, next slide. Yeah, this is about the STAMP extension for hop-by-hop performance measurement. So you know that STAMP enables active measurement of one-way round-trip performance between a sender and a reflector. So, but the performance of intermediate nodes is not available. So this draft aims to fill this gap and to allow to measure performance hop-by-hop. So if you want to do hop-by-hop measurement now through STAMP, you have to start a STAMP test session between for every intermediate node. This is a little bit complex. So this document aims to introduce a new optional TLVs to enable this performance hop-by-hop for each intermediate node. That of course is available to deploy this TLV. Several TLVs have been proposed. So of course, these TLVs can be activated selectively according to the specific needs. So there is a TLV for timestamp information. So each node must record, so need to record the timestamp at every intermediate node in order to allow the hop-by-hop measurement end-to-end, or direct loss TLV. In this case, each node needs to collect to record the number of test packets at every node, the hop-by-hop bandwidth TLV, the hop-by-hop interface error TLV, so, and also the IOM tracing data TLV. So these are proposals. So yeah, we believe that is something that can be useful to fill this gap also for STAMP to allow hop-by-hop active measurement. So of course, this is just an initial proposal, and your comments are very welcome to improve this document and to add further TLVs or further consideration about the application. So that's all. I hope to stay in 5 minutes.
Thank you. All right, we have a question from Greg, or a comment. We'll find out.
Greg Mursky Erickson. I believe this is interesting idea of complementing active performance measurement with a hop by hop. So give more information for analysis on segments of this path. I would probably look at it differently, and I believe already in the discussion on the milling list there was suggestion is to use IAM on. Okay, using the transport would not be but on the underlay network layer. Okay, so whether it's IPv6 or MPLS, so to apply IAM on their underlay layer rather than on a stamp layer. So
do you mean for the IAM tracing TLV?
Yes.
Yeah. For that.
So the thing is that then basically operator can choose, yes, I have my preference, I prefer direct export IAM, because it does not impact on the data packet and the bandwidth that is allocated for the service. But some might have a different view. But again, there probably easier will be, and it seems that logical, that hop by hop information be collected on underlay. And then again, yes, there is always question as how to return this information back to the sender. There will be a discussion I'm looking forward at 6-man, because there is a proposal for extension to ICMPv6. But I believe that, again, that probably not really needed, because this information can be distributed over the management plane. And if somebody wants to return it to the sender, stamp sender, then again, that's all doable. Okay, it's basically the flexibility of the local policy. But again, idea is interesting. I think that always, complementing, getting more information from the network is always helpful, but different level. Mm-hmm.
I agree. I agree with you. I also reply on the mailing list. And if there is a consensus to keep this option in this draft, I mean only the IAM TLV option. Of course, we can keep just to give a chance. Otherwise, we can omit and just keep the stamp TLV hop by hop for timestamp, for loss. I think, of course, we can discuss. If there is no consensus to use stamp to carry IOM information, hop by hop, of course, it's something that can be omitted. So all the TLV are independent, so we can just omit the IOM part.
Thank you.
What?
Rakesh?
Rakesh Gandhi from Cisco Systems. I was trying to understand how this would work. So the way stamp works is that you have IP header, and then you have UDP, and then the stamp payload. And when a node says, oh, the IP header, I'm the destination, I look at the UDP, and then I point or process the packet. That's how I do stamp processing. Now, this packet is going through hop by hop.
No.
How does a midpoint know that this is a stamp packet, it has a hop by hop thing I need to process?
Yeah, this is something that need to be, so it's just a proposal. So we can further discuss how to, so I mean, if the intermediate node is configured to handle this TLV, is configured to handle this stamp TLV option, let's say he automatically can be configured to put the information, to record information in the packet together with some identification and to move to the next intermediate node. So since it is an active measurement, I mean, when we start the active measurement from the source to the destination, we also know the intermediate nodes in some way, and we are able to configure that. If they support this TLV, they can participate to the measurement. Otherwise, if they don't support, we can make always hop by hop measurement without this specific node. So it depends if the intermediate nodes will support or not. So
yeah, but IP header
is something that needs to be discussed. For now, it's just a proposal, so it's just that need to be connected also with the overall stamp environment.
Okay, thanks.
But let's discuss. Thank you.
All right. Thank you very much.
Thank you.
Okay, next up we have distributed flow measurement. Trying to find this one. This one? Oh, there are two. Sorry. Let's just start with this one because we have it up.
Yeah. Can Can you hear me?
Yes, we can.
Yeah. Okay. Okay. Thank you. Yeah. This is Haji from China Mobile, and I will share the slides about the distributed flow measurement in IPv6 network. This is motivation why the distributed flow measurement without the controller is needed. For inbound network measurement, the controller collects data and calculates the quality of the traffic flow and optimize the forwarding path. The processing procedure is lengthy and difficult to guarantee the SL requirements. So additionally, in the inter-domain scenarios, the measurement data needs to be summarized, calculated, and presented on the centralized inter-domain controller. This interaction is complex between different level controllers. We also hope support the network measurement in scenarios where controllers are not deployment. Next slide, please. This is the overview. In the source node, the flow measurement data will be added into the traffic based on the method proposed in the previous draft. The intermediate or US node will record the measurement data and send that to the source node. Use a protocol like UDP or extended BGP protocol. More details can be found in the draft. Next slide, please. The draft extended the bitmap of the flow monitor option proposed in the previous draft. Next slide, please.
All right. Yeah, I think that's it for the content there. Thank you. Any questions, comments? All right. And again, for all of these, we'd like to see more discussion on the list around these if people are interested. Okay. So then the other one is flow measurement in V6.
Yeah.
Okay.
Yeah. Okay.
Great.
This is okay. Thank you. This just is about it's also about flow measurement in IPv6 network. This is an overview of the data. It's based on the auto-marking method that defines a new option to carry flow measurement data involving in basic or extended measurement flag that can be encapsulated in the hop-by-hop option header or destination option header. The key flag fields are flow monitor ID, not monitor ID, loss flag, delay flag, and measurement period. A steerable measurement period can be enabled in data plan by P flag. That is a measurement period. It can be better for flexible deployment. More details can be found in the draft. Next slide, please. This is the running code. Up to now, hardware device and software variants have been verified by laboratory test in China Mobile and China Telecom from 2021 to 2023. The implements are all based on this draft. Meanwhile, the field tree in China Mobile, Zhejiang Metro Network, and the government network has been finished in 2021. So next slide. So next slide, any questions or comments are welcome. We are seeking for adoption. Yes, thank you.
Okay, thank you. Any questions or comments here? Rakesh?
Rakesh Gandhi from Cisco Systems. So this is something that Greg said earlier as well, that there are extensions at the stamp layer or IOM layer, but there is also extensions at the at the transport layer. So for example, I think RFC 9343 defines IPv6 destination option to carry the marking. So, and now this one is marking for the at the IOM layer. So it's not clear to me how all this marking at different layers would work together. So some clarification would be useful. Thanks.
Yeah, thanks. Thanks for your question. It's a good question. Mm, maybe we can discuss this question in the mail list. Thanks.
Thank you. All right, and then last up, yes. All right. We have Xiaoming. All right. Xiaoming, I'm not able to hear you in the room if you are talking, but you can go ahead.
Can you hear me?
Now we can. It's a little loud.
Oh, okay. Motivations. According to updates to save to light and alternate mark method and IOM can all be classified as hybrid attack ones. The alternate marking method upstate for one upstate for three has been widely employing Upload network to implement performance measurements such as packet loss, delay, and GTS. However, upstate line one let's say basic IOM and upstate line 3 to 6 IOM and DX have some problem in doing performance measurement such as packet loss. We would wish to complement IOM by including the alternate mark message into IOM. Objectives our proposed solution does not intend to substitute for the existing standards, but augments the IOM's capabilities in performance measurement aspects. Next slide, please.
Just a note for the lightning talks, we want them to be relatively quick. So let's not, ideally, let's not read through all the text on these.
Okay.
If you just quickly summarize, maybe we can go to this slide and just summarize the proposal.
Okay. I integrated the alternate marking message into the best benefits of utility include I am in population load can call all the traffic of interest in with not a subset of packets. Thus, the fidelity of the performance such as packet loss can be ensured. And it mitigates the network and the received entity greatly. Furthermore, compared with the DX of type, the received entity needs much less precise overhead to calculate this count for packet loss computations. We are implementing performance measurement and OM trace monitoring currently, and IOM incorporate the DX option type into all the traffic of interest. Meanwhile, I am encapsulate load only need to select a very small subset of packets for IOM trace monitoring. For example, 1/10,000 of all the traffic. So the amount of exported data is significantly reduced to mitigate the network and the receive entities. We use the alternate mark message traffic flows split into consecutive blocks. Thus, measurement period is completely determined by the network devices. the receive entity does not lead to a concept about determining determination of a measurement period, but only compute this results each measurement period. The benefit to a uniform measurement methodologies. Let's please.
All right, and I do think it looks like we have two people in the queue, Greg and Justin. So maybe we can have those comments quickly.
And the format of extended DX type is depicted as follows. All fields are same as DX type format and defined in FC less 3 to legs except reserved field. The expanded DB option form used the most significant two bits of the reserved field, where 1 bit loss flags for packet loss measurement, D 1 bit flag for delay measurement, reserved 6 bit field reserved for future uses. Any considerations suggested code pod 5 is 5. Okay.
So we have some questions in the queue. So Greg, please go ahead.
Yes. I'm a little bit confused. IEM seems that it's capable of doing delay measurement and transit delay measurement. So from each IEM transit node. Yes, I agree that there might be some challenges, but exactly this form of header that you displayed from IEM DEX RFC includes optional sequence number, and sequence number seems to be sufficient to do packet loss measurement by just, following, expecting their monotonic increasing sequence numbers that would be probably increment 1 between the packets where the IEM header is included. So seems that there is a trade-off between defining these two flags for the loss measurement using alternate marking method versus using additional 32 bits for the sequence number and providing the same functionality. Am I missing something?
Okay, thank you. I will think about it. Thank you.
Okay. Yeah, we can talk about this, continue on the list. Thank you.
All right, and Justin?
Justin Yorman, New Liège. So basically the same question as Greg, and so also do we really need actually a new option type for that? Could it just allocate the 2 bits in the DEX flags registry? I don't know.
I suggest the registrations.
Yeah, let's do that on the list.
Yeah, thank you.
All right, thank you. It sounds like a good discussion for the list.
All right, and that was our last presentation. So thank you very much to everyone who participated. We had some good discussions. We have some potential new work to adopt. We have a few sector reviews to kick off. So I think it was a very productive meeting. And yeah, have a great rest of your week here at IETF.
It's not exactly the same. It's not the same, no. It's slightly different. It was actually the same factory or whatever.